So what I have here is just a laser. And what I'm going to do is put my ruler down and I'm going to draw a line along the laser line. So I'm just going to, with a Sharpie, draw right on top of that line so I can see it. Okay, so there's a black marker line. And there's a reason why I did that. So now what I'm going to do is I'm going to put this plastic block down. And we see something interesting. So here's my laser beam, which I haven't moved yet. And what was happening before is it traveled along this black Sharpie line, but it's not doing that anymore. It's actually bent. And that's called refraction. So refraction is the bending of light when it travels from one medium to another medium. So the initial medium is air, and then the second medium is plastic. So light's traveling through air, then through plastic. And what we can see is that it bent off its original path. Now, when I look over here, we see something interesting as well. So if this beam kept going straight, it would have followed this path. But it's not. It's actually bent one more time. So before, it bent to the left, and now it's bending to the right. And in fact, it's bending towards and away from the normal. So the normal, let me just put a dot here so I know where it was. If we were to draw a perpendicular line to the plastic. All right, so I'm going to put my plastic back. I think it was there. All right, so my black line is perpendicular to the surface. Didn't quite line it up. There it is. All right, so my black line is perpendicular to the surface, and what we see happening is it's moving towards the normal, and that's the way we talk about it. That's the terminology we use. So our beam used to be here, but it's actually bent towards the normal. It's gotten closer to the normal. Now, if we had done the same thing on the other side, put a dot so I know where my thing was. If I drew my normal over here, and the normal is just a perpendicular line to the surface. Oh, and I moved the whole thing. There we go, it's back. So this time, if this beam continued to go from the more dense to the less dense, it would have gone straight. But instead, it's bent away from the normal. And again, those are the words that we're going to start using. So bending towards the normal and away from the normal. Now, when we go from a less dense air to a more dense plastic, you always go towards the normal. But over here, when we went from more dense to less dense, we bend away from the normal. So that's what we're going to be talking about for the next day or two. Light traveling through two materials. When light strikes a translucent or transparent material, it bends or refracts. So that bending of light, where it seems to be taking a different path, the proper name is actually refraction. So we can say it refracts. The refraction of light is due to its speed changing as it passes from one material to another. So it's almost like if you're pulling a wagon along concrete and all of a sudden one wheel hits sand, what you'll see is it's going to turn a little bit and take a slightly different path. And I actually demonstrated that with the block prism. So depending on the material that light enters, it either speeds up or slows down. So for instance, if you were at the beach, pretend it's no COVID, summertime, and you're running in the sand, you can actually run pretty quickly. However, if you move to a denser medium, so that would be the water. So now you're in waist deep water and I say, okay, go, run. What you'll find is you run a lot slower. Light does the same thing. So in a vacuum and air, it's very, very quick. It's actually 3.0 times 10 to the 8 meters per second. However, in glass, plastic, water, those are denser materials. It slows down. So light slows down The more it slows down more, the more dense the material is. And that kind of makes sense because I travel pretty quick through air, not so quick through water, and I can't go through plastic at all. Rules for refraction. The incident ray, refracted ray, and normal ray all lie in the same plane. So what does that mean? Well, basically, if I have my incident ray is flat on the page, that means my normal has to be flat on the page, and my refracted ray also has to be flat on the page. It can't be all of a sudden sticking up like this or sticking down into the page. And there's two rules. And I mentioned this at the beginning of the video. So light bends towards the normal if it travels more slowly in the second medium than in the first. So light going from air to water or air to glass bends towards the normal. Light bends away from the normal if it travels faster in the second medium than in the first. So a good example of this is the pool. So if you were, say, a little fish underwater and you're looking up, so the light's going from the water into the air. Well, all of a sudden we notice in the water the angle's small, but in the air it's actually bigger. So that's saying the proper terminology is to say it's bending away from the normal. So the angle of refraction is bigger than the angle of incidence. And when you get to class, we're going to do a lab that demonstrates exactly this. So it'll be easier to understand.